Let's look at velocity time graphs. Let's start by looking at a position time graph. Let's say an object starts at x equals 0 and moves 8 meters in 4 seconds and moves at a steady rate. So we get a nice straight line. The velocity would be the change in position over change in time. In this case, the final position is 8 meters. The initial position was 0 meters. And the final time was 4 seconds, and the initial time was 0 seconds. This gives me a 2 meter per second velocity. And because the slope is positive, the velocity is positive. Now let's take this and create a velocity time graph to show this motion. So making a vertical axis labeled V for velocity and a horizontal axis labeled T for time. Since the velocity I found earlier is 2 meters per second, I will start at 0, 1, 2, 3, and have 1, 2, 3, 4 seconds along my horizontal axis. And I know that the velocity was 2 meters per second, and it was 2 meters per second every single time, because the slope of the line here is the same every single time interval. So this gives me a flat, straight, horizontal line. And if I write the equation for this line, it would be V is equal to 2 meters per second. Now this is for constant velocity, where a particle or an object moved from x equals 0 to 8 meters. So it would be like if our little person here moved 1, 2, 3, 4 seconds and ended up at 8 meters over here. Now really, motion isn't quite that easy, and we have more cases where objects are changing velocity. So let's look at that. Let's look at this case where there's a little car starting here at the beginning of the meter stick, and then we hit play, and we see that the truck is going. Now, what I notice about this is that the car or little truck started from rest and moved to the right. So starting from rest and moving to the right means that initially the velocity was 0. So if I was going to create a velocity time graph for the little truck, then I would want my initial velocity to be 0 at t equals 0. But we saw that it was definitely moving in the middle, and it looked like it was moving faster and faster because it went from not moving to moving a lot. So later in time, the velocity was much bigger. So maybe right here. Now if we connect these dots, that shows me that there is a change in velocity over the time change. So that shows me there's a rate of change of velocity, and we call that acceleration. So what would that look like on a position time graph? So the slope of a position time graph is velocity. So let's look at a couple of times. In this case, we have 0 time. Maybe we have 1 time, time 2, time 3, and time 4. So down here we would have 0 time, and then 1 time, 2 time, 3 time, 4 time. And if the slope of the line for the position time graph is equal to this value, because the slope of a position time graph is the velocity, then that would mean that my slope should be 0 at x equals 0, but then later our velocity is not 0, so that means that later our slope should not be 0. So it would look like some positive, because the velocity is positive here. So if we have our initial velocity defined and this later velocity defined, because of the slope of the line being equal to the value of the velocity, if we look at these little in-between times, the velocity is not 0, it's some positive value. The velocity is not 0, it's some positive value that's greater than the previous one, and so on. And so the velocity is increasing, which would mean that the slope at every one of these times, so if I go to this time, we've moved a distance, we're not at 0 anymore, and so our slope is not 0. And then later, we've moved a little bit more distance, or a lot more distance actually, and our slope is not 0. And then a little bit later, and our slope is not 0. And so you can see that as the velocity is changing, as our velocity is changing for every time interval here, as it's growing, so is the slope on our position graph. Now, if we put that together, we would get a curve, bunch of little lines added together would give us a curve. And that shows me that for every time interval, so look at these time intervals again, we are covering more and more and more distance. So we cover a distance, we cover more than that, more than double that. Then we cover even more and even more and even more. And so the rate at which the position is changing. And so that's a really big deal, that our position over time is changing with time. Now remember, this is velocity, and so that means that our velocity is changing over time, and that is our acceleration. So this graph here shows me that the object's velocity is changing. It shows me that it is speeding up because the slope goes from 0 to some positive value later. So it's speeding up. It's moving to the right because this is the positive positions all along my first quadrant vertical axis. And the velocity graph here shows me the answer to the question. What is the slope of the line at this time? Well, you go find the velocity on that graph. What is the slope of the line at this time? We'll go find the velocity from this graph, because the slope of the tangent line to this curve is graphed in all of those times.